Look at this coin flip sequence. Heads, heads, heads. Heads, heads, tails, heads, tails. 5 heads in a row. Does that look random to you, or does it look rigged? Here is the promise. Genuinely random data almost always contains streaks, clusters, and gaps. And your brain is wired to read those patterns as proof that something is fixed. Let's see why. Most people expect random to look like this. Heads, tails, heads, tails, heads, tails. Constant alternation. Neat. Balanced. But that expectation is wrong. True randomness is lumpy. It does not smooth itself out. If every flip is independent, the coin has no memory, and streaks appear naturally. This is called the clustering illusion. Our brains treat clusters as signals of a hidden cause, when clusters are just what random noise looks like up close. Imagine scattering raindrops on a sidewalk. Some squares get hit twice. Some stay dry. That uneven pattern is not evidence of a targeting system. Look at 2 dot grids. The left one looks random, but every dot sits far from its neighbors. The right one is actually random. It has clumps and gaps. The evenly spaced grid feels correct because our intuition equates fairness with regularity. But regularity is a fingerprint of design, not chance. Now, the key twist. Predicting an exact streak before it happens is very unlikely. But seeing some unusual streak somewhere across many trials is almost guaranteed. Flip a coin 100 times, and a run of 5 or 6 heads is ordinary. It only looks suspicious because we notice it after the fact. When people invent a random sequence in their head, they avoid long streaks. They alternate too often. The fake looks smoother than the real thing. Statisticians can often spot a faked sequence just by counting the longest run. The invented one is missing the streaks reality would produce. So streaks are not proof of manipulation. They are the natural texture of chance. But that does not mean every suspicious pattern is harmless. To tell real bias from random noise, you need a rule set before you look at the data. Otherwise, every data set will hand you some pattern. Here is a practical test. Define the expected pattern in advance. Fix the sample size. State the comparison rule. Then check whether the data actually breaks it. Without that rule, you are pattern matching after the fact, and the brain is spectacular at finding shapes in noise, whether the shapes were placed there or not. Think of the lottery. Any specific winning combination is astronomically rare, but somebody wins almost every week because the drawing runs over and over. The same logic applies to coin flips, dice rolls, stock ticks, and dot grids. Rare events become common when the process gets many chances to produce them. So before you call a streak suspicious, ask one question. Did I decide what suspicious means before the data arrived, or only after I saw the pattern? Random data will always look a little rigged. That is the shape of chance. For another probability illusion, check the blind spot playlist.